Hey guys, we're going to go over some review for the test, okay? I'm going to go fairly rapid fire. Make sure to ask questions where needed inside the actual classroom. So we're calling this Chapter 6 Review. Welcome to my laboratory. That was weird. Alright, here we go. Find the general solution to the exact differential equation. Okay, so to get rid of the dy over dx, we're going to integrate both sides, right? Well, actually, you're kind of doing it. So you're moving over that dx. And then you integrate both sides, because then you get y equals, remember our rule, 5x to the 5th over our new exponent, which is 5, minus, you have to have this one memorized, guys. The antiderivative of secant squared is tan of x. There's no way around it. You just got to know it. And then plus c, because we're finding the general solution. We don't know what level we're going on. Derivative of a constant is 0. So the antiderivative, we have to put a plus c, not z, in it, right? Make sure you know your secant squared. Make sure you know cosecant squared of x is your negative cotan, actually, because the derivative of cotan is negative cosecant squared. Make sure you know those two going into it. I probably will throw one of these on there because I'm mean. All right. Number 4, it has to say x is greater than 0 because, well, it can't equal 0. It won't work. So again, let's move the x over, and we integrate both sides. The antiderivative of 1 over x is natural log of x. That's another one you gotta know. It's actually absolute value of x minus. Now we turn that 1 over x squared into x to the negative 2. It's minus. Because remember, the exponent is at the bottom. We can move it to the top and just make the exponent negative, right? So the antiderivative of negative x to the negative 2 is x negative 1, because negative 2 plus 1 is negative 1, over our new negative 1 plus c. We can make that positive. Again, plus c, general solution. Alright, let's do this piece. We're going to make a slope field, right? Which problems are we doing? 1 second, I got. Alright, we have to do 32 and 33. Alright, 32 I'm going to do in red. So when you plug in 0, 0, you get 0 minus 0, which is a straight line. Plug in 0, 1, you get 0 minus 1, which is negative 1. 0, 2, you get 0 minus 2, which is negative 2. 1, 0, you get 2 minus 0, because when you plug it into that, it's positive 2. Oops. 1, 1, you get 2 minus 1, which is 1. This is terrible. Oh well. 1, 2, you get 2 minus 2, which is, or 2 minus 2, which is 0. How am I right? So, oh, my mobile's crooked. Alright, so we plug in negative 1, 0. You get 2 times negative 1. I'm sorry, 0, negative 1. You get 2 times 0 minus negative 1, which is a positive 1. Whoa! There you go. That's better. 1, negative 1. So you get 2 times 1 minus negative 1, which makes it plus. That's 3. That doesn't look like 3, but oh well. Negative 1, 0. You get negative 2. Negative 1, 1. You get negative 2 minus 1, which is negative 3. Whatever. Negative 1, so that's going to be negative. This one's negative 4. Whatever, close enough. And negative 1, 2 times negative 1 minus negative 1 is negative 2 plus 1 is negative 1. Alright, so that's number 32. Not so bad, not so bad. Again, that's 32. So let's do 33. 33 I'll do in blue. So we're doing x plus 2y. So we got 0 plus 0 is 0. 0 plus 2 is 2. That's not even close. 0 plus 4, because your y is 2. right? 0 and -1. -1 times 2 is -2. All right? Now all the x's are 1. 1 plus 0 is 1. At 1, 1, we're going to do 1 plus 2 times 1, which is 3. 1, 2, we get 1 plus 2 times 2, which is 5. So that's going to be our steepest slope. That's not bad. 1, -1, you get 1 plus 2 times -1. So that's -1. Alright, now we're here, -1. -1, 2. -1 plus 4 is 3. -1 plus 2 is 1. -1 plus 0 is -1. -1 plus -2 is -3. There we go. That's much better. So that's my slope field. Again, you're just taking your x and y coordinates and you're plugging them in, and that'll give you your slope at that given point. And you just kind of guesstimate what those slopes are. All right. All right. I don't know what I'm doing anymore. I got paused. We're finding the indefinite integration of this. Antiderivative of cosine is sine, because derivative of sine is positive cosine. Now the integration of sine is negative cosine, because the derivative of cosine is negative sine. You guys got to know that going into this, all right? Minus 3x to the third over 3. So those cancel. Again, add 1 to the exponent, divide by your new exponent, plus c. That's how they got it. That c is because we're indefinite. We don't have points to plug in. Okay? More problems. Okay, now this one again, same thing. 3x to the fifth over 5, our new exponent, minus 2x to the -2, -3 plus 1, over -2, plus antiderivative of secant squared is tan. I told you to know those, plus c. Our 2's cancel, our negatives become positive, and that's how they got that answer. Again, know your trig stuff, guys, going into it, please. Alright, antiderivative of 2e to the x is 2e to the x. Secant tangent is secant. Just like cosecant, cotangent is negative cosecant. Know that going into it. Whoops. That was a weird noise I just made. Please. Minus, now you gotta change this to x to the 1/2. Remember, we have to deal with actual exponents that are numbers, right? We don't just have any quick rules for that. So 1/2 plus 1 is x to the 3/2 over our new exponent. So you move that 2 up, and that's how you get 2x to the 3/2 over 3 plus c. Okay, you gotta get those exponents to numeric values, just like we did with derivatives. You guys remember that? No? Yeah, kinda. Alright. Alright, U-Substitution. I gotta check. Alright guys, I'm back. U-Sub now. They give us U. Okay, so now we gotta convert this all to one variable. We need to get to U instead of x's. So we take derivative of both sides. Derivative of U is du. Derivative of 2x squared is 4x times the derivative of x. So now we gotta get dx by itself, so we can substitute it in right up there. Right up there. I don't even know if I'm putting it the right way. So we divide both sides by 4x. And now I can plug this in for dx. And this in for my 2x squared. So I'm doing antiderivative of x cosine of u dx over 4x du, because we're taking it. My x's cancel, thankfully, because if they don't, we can't do this. And I'm going to pull the 1/4 out in front. What's the antiderivative of cosine? Well, it's negative sine, so I get negative sine over 4 of u. And now I have to plug in my u. So I get negative sine of 2x squared over 4. And don't forget your plus c. All right? All right. Good. Great. Grand. We're almost done. Another u substitution. They give you the u. So we're going to take derivative of both sides. Derivative of u is du. Derivative of 1 is 0. Negative r to the third. 3 comes out in front. Make 3r. 3 minus 1 is 2. dr. So divide both sides by negative 3r squared. I'm ready to go. So we're taking the antiderivative, 9r squared, over square root of u, right, times du over 3r squared. Negative. So our r squareds cancel. This becomes negative 3. I'm going to pull out in front. It's negative 3, antiderivative of 1 over root u du. But now I'm going to change that 1 over root u into, that's 1 over u to the 1/2. So that's u to the negative 1/2, right? Right? 1 second. So I get negative 3 u, negative 1/2 plus 1 is 1/2 over 1/2 plus c. So I move my 2 up. So I get negative 6 u to the 1/2 plus c. But now I got to go through and plug in my original u. And there we go. Fun stuff, isn't it? I gotta go check for time. Alright, I'm back. Alright. One more, but they don't tell us what to substitute for u. But I see a function inside of a function. So my u, 1 minus x. Okay? Take derivative of both sides. Derivative of 1, 0. Derivative of negative x is negative 1 dx, right? So we bring the negative over, and I'm ready to go. So I'm going to do, sorry about that, some freshmen being fresh. I'm ready to go. So I take my antiderivative. Now I plug in du over negative 1 for x, so negative du for dx over u squared. Okay. So I'm going to convert this u to the negative 2, pull my negative out in front, du, because we got to bring that u from the bottom, right? So I get negative u, negative 2 plus 1 is negative 1, over negative 1. So that just becomes negatives cancel. And I'm going to move that u back to the bottom, 1 over u, plus c. Now I'm going to go ahead and plug in my original u, 1 over 1 minus x plus c. That's my final answer. Yippee-yi-yo-ki-yay. Alright, separation of variables time. Whew! Alright, we're given this equation, asked to solve it. So what I'm going to do is I'm going to switch my dx and my y to get all my variables on the same side. So you get dy over y equals dx over x. And now to get rid of those d's, I'm going to integrate both sides. Or study harder so I don't have a d. I'm sorry. Antiderivative of 1 over y is natural log of y equals natural log of x plus c. Now I get y by itself, so I have to take both sides as a power of e. Those cancel, so I get y equals e to the natural log of x plus c. Now that's close, but no cigar. Now, what I can do is change this to y equals e to the natural log of x, right, times e to the c, right? Right, yeah, so I get y equals x times some number c. Didn't that work out nicely? So now I have to go back up here and grab these 2 points and plug them back in to find out what c is. So I'm going to set y equal to 2 and x equal to 2. So you end up with 1 equals c. So my final answer is y equals x. Isn't that silly? That's crazy. Super easy. Not really. Super easy. Alright, let's do another one. You guys have seen this one before. Alright. First thing I'm going to do is manipulate my right side, make this e to the x over e to the y. Okay? And now I see my x's are across, turn my y's are, so I'm going to cross multiply. So I get e to the y dy equals e to the x dx, right? So now I can integrate both sides. So I get e to the y, because the antiderivative e to the y is e to the y, equals antiderivative e to the x is e to the x plus c, right? So now I have to get rid of that e to the y, right? Right. So I natural log both sides. Those cancel. You're left with y equals natural log of e to the x plus c. Okay, now we have to figure out what this c is. So we have to plug in these 2 points. So we set 2 equals natural log of e to the 0 plus c. E to the 0 is just 1. So we take each side as a power of e to get rid of that natural log. So you get e to the 2 equals 1 plus c. Subtract 1 from both sides, you get e squared minus 1 equals c. And you can leave it like that. That's actually great. So my final answer is y equals natural log of e to the x plus e squared minus 1. All right, check for time.
This is the last question from the test. Polonium-210, the number of radioactive atoms remaining after T days in a sample of polonium-210 that starts with y to the 0 power, radioactive atoms is y equals y to the 0 power e negative 0.005 T. Find the element's half-life.
All right, I'm back. Here's how you do it. We use our formula. Half-life equals natural log of 1/2 over your k. And when you do that, you get 138.6. That's it. That's all there is to it, guys. Don't blow that one. Please. All right. Last one. How do you know if this one's on the test? Let's do it anyways. So you want to know when there's 95%, or after 95% is present on the day the sample rise has disintegrated. So 95% has your sample not be useful after 95%. So we want to know how long it will take for 95% to be gone, or to be there. To be whatever. Whatevs, bro. Okay. Oh, they're asking when are you going to be down to 95%. So we take 0.05, because that's 95% disintegrate equals 1 e to the negative 0.005 t. Right? So I divide both sides by 1. Oh, look at that. It doesn't change. So I get 0.05 equals e to the negative 0.005t. So I natural log both sides. I natural log both sides. So I get natural log of 0.05 equals negative 0.005t divided by negative 0.005. And, well, I don't cancel that. That's wrong. I get 599 days. I don't think I put that on test. It was just continuation. Enjoy. Ask me questions. I'll read the